Hello everyone, welcome back to my channel. This is Back Camera Guy for you. Hope my video finds you well. And this video is a continuation of my last video where I left the topic by asking a question like why a piece of metal or material starts glowing when we apply heat. Now, for that, let's uh, uh, step back a little, okay? So you remember, like when we pass a beam of sunlight through a prism, it breaks the sunlight um in seven colors of rainbow, in a particular order, right? So first we see violet, then indigo, then green, then yellow, then orange, then red. At least that is what our eye can detect, right? Now, uh, what is happening here is like uh, the light is a uh, wave. In one of the explanation of what light is light is a wave, right? And wave meaning, and where the wave is traveling through, it is traveling through the electromagnetic field. We have electromagnetic field everywhere, that is the idea. And when we create a ripple on that electromagnetic field, it creates light. That is as simple as that, okay? Now, how we can create a ripple, right? So we have to um, make a vibration, of course. Like that is how we create ripple. We have to make a vibration. We have to apply something so that it vibrates something, right? Now, in order to create ripple on electromagnetic field, we have to also vibrate something, and that is nothing but a charged particle. For example, electron is a charged particle. If we can create a vibration with electron, if we jiggle the electron, it will create a ripple on the electromagnetic field. And if the ripple is strong enough, then we can see them. For example, if uh, there's enough ripple in the electromagnetic field, right, then we can see yellow light, right? Like uh, the wave of the wave that is going through electromagnetic field. If the distance between two peaks of that wave, right, is sufficient enough, if it reaches a particular size, right, then our eye detects that electromagnetic wave as yellow light. Now, if the length of those two peaks of that wave is greater than yellow light, then we'll see light which is orange. If it is even greater, then we'll see red color. Similarly, if we go the other side, then the size of the wave is shrinked down. It's narrower. So if it is narrower than the yellow light, then it will become green. Even narrower, then it will become indigo. Even narrower, then we'll get violet. But is that the end? Well, if we shrink it more, then what we'll get? We'll get ultraviolet light. Maybe as human we cannot see ultraviolet light, but birds can see ultraviolet light, right? Some of the birds can see ultraviolet light. And then if we go further down, like if we shrink those wavelengths further, then we'll get X-ray and so on. Likewise, on the other end, after red, if we make the like distance between two peaks little wider, more wider, then we'll get uh, infrared. Of course, our eye cannot detect infrared light, but using an infrared camera, we can easily detect infrared light, right? If we go farther down, right, if the wave is further like wider, then we'll get what we'll get radio wave, that invisible light which I was discussing in the last video, right? So it's just the wave. The size of the wave determines what kind of light we are seeing. That's it. So when we heat up a piece of material, right, what happens is, at least the earlier understanding was like that. It is a mechanical wave, right, and it makes the electron jiggles. Now, as the electrons are jiggling, it's creating a ripple, and that ripple is actually coming, like we are detecting them as light.